Okay, so this lesson is on functions. This is a really important concept in math classes, Algebra 1, Algebra 2, pre-calculus, calculus. It's a pretty important concept. Okay, so today we're just going to determine if a relation is a function. Okay, before we get started, I would like you to look at this picture and estimate what percent of this pie has been eaten. We'll pause here. Okay, how do I determine if a relation is a function? Well, first of all, it helps to know what a function is. So a function is a special relationship where each x value has exactly one y value. So, for example, every x should go to only one y value. In other words, 1 goes to 7, 2 goes to something 6. They could go to 7 as well, just has to go to something. Now, that would be a function. Now, the problem arises is if you have another something like a repeat in the x and then it goes to a different value like 5. Okay, so now 1 goes to 7, but it also goes to 5. So 1 really goes to two different y values. So that would make it not a function. So function is where each x has exactly one y value. And so if I get rid of that, now this is a function. All right. Okay, so how do we tell? So we can look here. This first one is a function. I've got x, 0, 5, 7, and 11. And notice that each of those go, there's no repeats there, so that's kind of easy to tell. They each have their own y value, 6, -2, 9, and -1. Okay, now it's not a function if you really see, I've got -4, -1, 5, and then another -1. So that's a red flag because now I notice that this goes to 7, -1 goes to 7, and it also goes to -2. These are two different y values, okay? And that's not good. So how can we tell if it's not a function? The shortcut way is to look to see if the x values repeat. So notice here we have a -1 and a -1, and those repeat, and the y value then goes to two different numbers, okay? So really shortcut way of looking at this is look at your x values, okay? And then if they repeat, it's not a function. If none of them repeat in the x values, you're okay. Okay, so only x, that's the shortcut way of telling if it's a function or not, from ordered pairs or a table. So if we look at this, are these a function? So let's take a look at that first one. 11, 6, 5, -2, 7, 9, 11, -1, and 4, -8. Is that a function? Okay, and that would be, this is no, not a function. And again, here I have 11. 11 in that first ordered pair goes to 6, and now 11 goes to -1, so it goes to two different y values. So that's a no. The second group there, I've got 4, -7, 6, -7, 8, -9, 10, -7, 12, -9. Now, I want to look at the x's. Do I see any repeats in my x's? No. So this is a function. Now notice in the y's I have repeats. That's okay for it to be, it could all be the same number. It could all be -7 and that would still be okay. As long as the x values don't repeat, then we're good. So each x value does have its own y value, go to only one y value. So this is a function. Okay, so that's ordered pairs. And again, ordered pairs can be written as a table too, so you're still looking for the same thing. Do you see any repeats? Yup, so this is not a function. Okay, do I see any repeats over here on the right? I don't. Notice -2 and 2, those are two different numbers here, so this one is okay. This is a function. Again, I'm just looking at just the x values and then seeing if those repeat. Okay, that's how you determine it from a set of ordered pairs or from a table. Now, a mapping diagram, it's a little easier to determine. And if it's a function, then each of these right here, each of these x values should only have one arrow coming off of them. So in other words, each x should have only one y, so it should only go to one y value. So this is a function. Notice all of those go to only have one arrow coming off, and they go to one number. Okay, so on the second mapping diagram there, you'll notice here this is not a function, and the reason for that is that 6, it goes to 3, and it also goes to 5. A function, each x should have exactly one y. Well, this one has two y values, 3 and 5. So this is not a function. So that's how you tell from a mapping diagram. Okay, and then lastly, how do we tell from a graph? Well, from a graph, we use the vertical line test. So we draw a vertical line. If the vertical line intersects the graph more than once, it's not a function. Otherwise, it's okay. So this is only used for graphs. So I'll use a vertical line, draw. So this first one, if I draw a vertical line anywhere, it should only pass through once. Notice it would just pass through once. So I should be able to do that anywhere on the graph, and it should only pass through once. If I can find a spot where it would pass through more than once, then it would not be a function. But this one is good. Notice each vertical line I draw there only passes through once. This graph on the right is not a function because if I can find a spot where it passes through more than once, it's not a function. And notice right there, not a function because it passes through twice. Now you could find other spots on here, like right here, also passes through more than once. So if you can find anywhere on the graph where it passes through more than once using the vertical line test, it's not a function. Okay, so let's look at some discrete and some continuous graphs. This first one, again, can I draw a vertical line? Should pass through once. Okay, we're good there. Now here, if I draw a vertical line, it doesn't pass through anything, but that's okay. Only once. Once. So everywhere I draw a vertical line, we're okay. So this one is, yes, this is a function. Okay. All right, how about here? Well, let's see. Draw, again, you can draw it wherever, but I like to go through the, okay, so this first one that I drew, notice it passes through here and here. That's twice. So this is not a function. The other ones are okay, but if you can find even one spot where it passes through more than once, then it's not a function. So that's a no. All right, how about this one? Draw a vertical line right off the bat, passes through more than once, so that's no. Okay, how about this one? So those arrows on the end, remember that just means it keeps waving, keeps going up and down. So if I draw a vertical line here, I'm good, it goes through once. Just once. Once. Looks like I'm pretty good here. I don't see any spots where I would go through more than once. So this is a function. Okay. So now you've got it down. If you are given a mapping diagram, shortcut is to look to see if the x values repeat. If they do, it's not a function. Okay? And we did a couple examples. That is the case if you're given a set of ordered pairs or if it's given to you as a table. Okay? Mapping diagram, look at the x values. If there's any x value that has more than one arrow coming off of it, it's not a function. And then for graphs, use the vertical line test. If you can find draw a vertical line that passes through the graph more than once, it is not a function. And that is how you determine if relations are functions. Okay, so you have an assignment on this, and all you're doing is determine if it's a function or not. You're just going to write yes or no. All right, see you later.